Yeah, so the interesting history in Ontario is that AMI was mandated about 15 years ago. And AMI was mandated because the government wanted to bill on time of use pricing. So all the utilities scrambled, I think you can say, to put in AMI meters. So for a long time, AMI was used for billing, and that was it. So now these meters are becoming end of life. So they're about 15 years old, they need to be replaced everywhere. And the terminology AMI 2.0 has become pretty common now. And sometimes utilities don't fully, I think, understand what AMI 2.0 means and what it could mean. Because it's easy to equate it with, it's just the next iteration, it's the replacement, and we need to do it, and it's the second meter that we put in. But what this terminology kind of hides and covers is the new opportunities that it brings, and really the new technology that goes into these meters. So now you have modern meters that have DI capabilities. So they have distributed intelligence cards right in the meter. So it's essentially like installing a smartphone at every house. So you can't just monitor the flow of electricity, you can gather a lot more data from it, and you can process it right at the meter and right at the grid edge. And that's what makes it so exciting and so powerful, because now this whole idea of grid edge computing, and I really prefer that terminology, allows you to have this distributed way of analyzing data, collecting data, and using this data for real purposes. So all of a sudden, you have distributed intelligence everywhere that illuminates your grid. So distribution grids, even with AMI, were mostly blind from kind of the substation downwards, but now it's essentially installing a sensor at every household. So you can gain so many insights and create much more efficient grids by having this data and utilizing the data. I would say in terms of use cases, there's usually two categories. One is the grid benefits, and then the other one are the customer benefits. So in terms of the grid benefits, utilities really can gain insights into electricity flow right down to the household level that they've never had before. So they can get much more granular insights into peak times. Rather than seeing it as a system peak, they could identify more local peaks. They could identify more load imbalances, outages, and so forth, and react in real time. So really having this visibility allows them also to create a much more efficient grid. So it gives them more information of where do they really need to upgrade an asset, or where could they come up with a non-wires alternative to defer their capital, and overall hopefully lower the cost by making the whole grid more efficient. And then on the other side, you have customers. And customers have become a lot more sophisticated and demanding when it comes to customer service and insights. So, and why that's important for utilities is not just for customer satisfaction, but it's also getting customers to engage and be a part of the whole electricity system. So for example, if you provide insights to customers as to how they use electricity today and how they could use electricity more efficiently, for example, based on their current usage, and by making small changes that could potentially real big impacts on the type of infrastructure that needs to be built and the type of service that needs to be provided to them. So by giving customers more information about their own electricity usage, by giving them real opportunities to engage with their usage and maybe change their behavior and incentivize them for behavior changes that are beneficial, you can really solve problems in a very, very different way than in the past.